Today we will have a experiment or a demo to see the line following robot, how it will work. So by doing that, we'll have to use an infrared sensor, an IR obstacle sensor. So we'll study how to connect this one and to simulate what is the output of this and how to use this on our simulation using the Proteus. So we have here an IR obstacle sensor, and we have three terminals here, output. Okay, so this output, it's either 1 or 0 here, digital, but it is have a value of 5 volts or 0 volts. So this one will be connected to the Arduino when your Arduino is being programmed for the line following robot. And then the second terminal here is the ground, and VCC or supply voltage, which is 5 volts. Now this test pin is not included actually, but in order to simulate this, we have to use this test pin, and we have to connect this on the switch. This is for demo purposes only. This is not really a part of the circuit. This switch simulates how the IR transmitter and receiver will work. Okay, so that means here, if I will switch it to a black here, which means that if there is a black tape that we will be using for the line following robot, so that means there is a black tape to be sensed. Okay, and if you will put on the other side, which is none, there is no black tape to be sensed. Okay, so here, if on the none mode, okay, there is no black tape to be sensed, the infrared receiver and transmitter will communicate to each other and will have a 5 volts here output. Okay, but if on the black mode here, which means there is a black tape to be sensed, the communication between the two will be disrupted because the IR signals will be absorbed by the tape because it's colored black, and the signals will be absorbed and there will be no transmission here. So therefore the output here will be 0. Okay, so in order to prove that, we have to connect this sensor to a voltmeter here. Okay, so the output will be connected to the voltmeter, connect it here, and this one I will be connecting it to the ground. I will connect it to the ground. Okay, and also I will connect this to the ground. Okay, and this VCC terminal, I will connect it to the power supply. This is a symbol of power supply, which is 5 volts. Okay, and to simulate, I will use the test pin here. Now remember, this is not present on the actual board, but this one, we have to use this for simulation purpose. Okay, so on this test pin, I will connect this to the path switch. Okay, and the none mode here will be connected to the power supply, and the black, which is the black tape detection, I will connect it to the ground. Okay, so now since the circuit is already completed, I will simulate this. Okay, now on this black position here connected to the black, that means there will be a black tape, which is the path of the line following robot. Okay, say for example, this black tape is to turn right or left. So whenever there's a black tape, there will be 0 output since the transmission of the IR will be absorbed by the black tape and will be disrupted. So therefore, there is no voltage at the output. There will be no voltage at the output or wherever it is connected to Arduino's terminal. So if I will switch this up, which is no black tape, okay, so the IR signals will not be absorbed and it will be transmitted to the receiver. Okay, so there will be communication here and there will be a voltage output of 5 volts to be connected to the Arduino. Okay, so remember the colors here. Black or red is that means it is 5 volts. It's a 5-volt output, and blue is 0, so it's connected to the ground. So see here again, I will switch it below 0, which is blue, and red, which is 5 volts. Now we have a sample program here for the line follower robot. So consists of 2 motors, so and two infrared sensors. So we will use 2 infrared sensors to sense the left path and the right path, and we have 2 motors. So here we have the connections to the pin of the Arduino. So here the left sensor, the left infrared sensor should be connected at pin 2. The right infrared sensor should be connected at pin 3. So there are 2 terminals for each motor. So the first terminal of the motor, we will assume first which is positive or negative of the motor. So that we will be consistent, and there is no problem to reverse the motor, the connection of the motor later on. So here we shall tag a motor here M1A, so it will be connected on pin 5. Okay, for the left motor. Okay, for the left motor, say the positive terminal will be connected on the pin 5, and the negative terminal should be connected at the pin 4. While on the right motor, the positive terminal should be connected at pin 7, and the left terminal should be connected at pin 6. So we have now the definitions of the terminals, whether it's an input or an output. So the left and the right sensor should be input, and the terminal used for the motors will be output. Okay, so here's our loop now, and this is how the logic goes for the turning of left and right of the robot, and when should it stop and when should it run straight. Okay, so here for the first one, for moving forward, we have here an if statement. So if the 2 sensors has no detection, you can see here, if the 2 sensors has no detection, so the positive terminals should be at the high. So LM1 is high, so it will turn the motor forward, say for example, and also for the right motor, which is RM1 is connected to the positive also for the motor, it should be both high, so they have the same direction. If there will be no detection on both sensors, the left and the right, so therefore the robot will move forward online. Okay, so we can test also if upon you will turn on the switch, because there will be no detection because you have to put the motor first on the path. So while you are holding the motor, it is expected that the 2 motors, the left and right motors, should rotate on the same direction, which is forward. Now, for the second if statement, this will be turning right. Okay, this will be turning right, and then here, if, okay, there is an if statement again, and it is should be operated together. Okay, because the and statement requires that this should be on, and this should be off because there is an exclamation point. So this means that it is a not. Okay, so if the left sensor has no detection and together with the right sensor has detection, because now it's off, that means there is a black tape detected by the right sensor. There's a black tape detected by the right sensor. So we can see the output here. Okay, so LM1 still high, that means it's forward. But see here, RM1 is low and RM2 is high. So it is reversed. So therefore the right motor will be reversed momentarily, and this will cause the motor or the robot will turn right. Okay, so now if the detection is over, these two will both again high because there will be no detection anymore. Okay, so the next statement if is turning left. Okay, so that means the left sensor will detect the tape, the black tape. Okay, so there will be a 0 result for the output of the sensor, and there is no detection on the right sensor. So this should be together. So let us observe the output here. Now the left motor, you can see LM1 now is low and LM2 is high, so this should be reversed. While the right motor, RM1 is high, so this will be forward. So the effect of this is the line robot will be turned left. Okay, so when there is no detection again, it will revert here on this condition. So the robot again will turn. I will move straight. Now the last if statement. Now here you can see finish line. So the robot will stop. So both motors will stop. So that means the right and left sensors will detect a black tape. So that means a tape will be connected perpendicular to the path so that both sensors will detect the tape. So if the left sensor detects the tape and the right sensor also detects the tape, now you can see the condition here. So both are or all terminals will be 0. So there is 0 volt because all are low. High means 5 volts and low means 0. So the effect of this, both motors will stop. So the robot also will stop. So we can see now the terminals of the motors and the sensors, which terminals of the Arduino will be connected. So we will connect the uh, motor and the sensors to the Arduino. Okay, so we have now our Proteus software. So we have the things that we need: the Arduino, okay, and the L298 motor driver, the two IR sensors for left and the right. Okay, so this switch only is not the part of the circuit, but to give only signal to simulate the IR sensors. And we have the two motors here, and here we have already the labels, okay, in order for simulation, and we have the Arduino. Okay, so here to connect this, okay, first we have to connect the motor driver to the power supply. So we have here 12 volts. It should be connected to the 12 volts here. Okay, and we'll add the ground. We'll add the ground here. So this is the supply for the motor. So this will be connected to the ground. This one also connected to the ground. Okay, and these two terminals should also be connected to the ground. Okay, so I will add another ground here. Okay. Okay. So grounds are connected. Okay, and we'll add the power supply symbol for the 5 volts. So I will connect this to the 5 volts. And we will not control the speed of the motor. So these E and A, enable A, and B can be connected directly to the power supply. Okay. Can be connected directly to the power supply. Can make this straight. Okay, so it's not on the grid line, so there's no problem with that. There's no I didn't put a snap to grid line. Oh, it's already snapped, but the terminals are not actually on the same grid. Okay, so how about on the connection of the motor? So here for the motor, so I will connect it here. This, okay, we'll connect this to this motor. Okay, for the left motor, we'll connect it also here for at the terminal. Okay, so also here we will connect this to this motor. Okay, and the other terminal will be connected to the other terminal. Okay, so now we need to connect this to the Arduino. Okay, the IN1, IN2 for the left motor, and IN3 for IN4 for the right motor. So here on the sensor, also we'll connect it to the Arduino, but this one first, we'll connect this to the Arduino. So the left motor, the LM1, okay, so as we can recall, okay, pins 2 and 3, okay, pins 2 and 3, 2 will be connected to the left sensor, 3 to be connected to the right sensor, LM1 is connected to pin 5, LM2 is connected to pin 4, RM1 is connected to pin 7, and RM2 is connected to pin 6. Okay, so here we will connect LM1 to the pin 5. So LM1, I will select here IN1. Okay, IN1, I will be connecting this to pin 5. Okay, so this is your IN1. Okay, so I will move this one so that it will be visible. Okay, okay. So LM2 will be connected to pin 4. So that is IN2 should be connected to pin 4. There is pin 4 here. Okay. Okay. So this is LM1 and LM2. Okay. So this is your IN2. We'll move this one. Okay. Here you can see. Okay. So the next connection is pin 7, which is RM1. So this will be IN3. Okay, so this is your RM1. So I will connect this to pin 7. Connect this to pin 7. So pin 7 is here. We'll connect this one here. Okay. So seems looks like a short circuit, but it is not. So I will just drag the connection here so that it could be visible. Okay. Okay. Then for the RM2, it will be connected to pin 6. So that would be IN4. Okay. And I will connect it to pin 6. Pin 6 is here. I will connect it here. Okay. So this is now our connection. Okay. So I will drag this one to make this straight. Okay, doesn't matter. Okay. So after that, we will connect our sensors. So the left sensor will be connected to pin 2. So we will put first the power supply here. Okay, I will put power here. Okay, connected to VCC, and ground should be connected to ground. Okay, same thing here, ground, and I will put power also to VCC. Okay, that is 5 volts. And the output of the left sensor will be connected to the pin 2 of the Arduino. So this is your pin 2. Okay, I will connect it to the left sensor. Okay, and then the right sensor will be connected to the pin 3. So pin 3 here, we connect it to the right sensor. Okay, so the test pin, in order for simulation, the test pin should be connected to the left sensor switch here. This is not a part of the circuit. This is just for simulation. Okay, we can drag this connection down. Okay. Okay, no problem. And then the right sensor, we will connect it also to the right test pin. Okay. Now remember that we should connect this also. This part of the switches will be connected to the power supply and also for the ground. So for the non-detection here, that means there is no tape that can be detected by the sensor. I will put the power supply here. Okay, so I will connect this to the power supply. and also we'll connect this to the power supply. Okay, and these two terminals that for the detection of the black tape, I will put a ground there. Okay, so that is our connection. Okay, that is our connection. So we'll run the simulation now. All the connections are connected. All the required connections are already connected. So we have the motors connected, the sensors, and the terminals from the Arduino to the motor driver. Okay, so we will run the simulation. We will see, we will run the simulation. So the program is already loaded here on the Arduino. So we have to start the simulation. So I will click play the simulation, and we can see now that the motor is now rotating. It is now very slow because the CPU load is very high. But anyway, we can see the rotation there. So I will close up on this part. Okay. So if I have a stronger computer, faster computer, so this should be also fast. Okay, so we can see that the motors are turning on both directions. Now you can see the position of the switches or the sensors. That means there is no detection of black tape here. So according to the program, both motors will be on the forward direction. Okay, both motors in the forward direction. So how about if it will turn right? So if it will turn right, that means there will be a detection on a black tape here. Okay, so there will be a detection of the black tape. Now see on this position, both are turning on a forward direction. This is 5 volt supply, okay, to the Arduino. You can see here the switch is in direction, so therefore there's no detection on the sensors, and it gives 5 volts to terminals 2 and 3 for the Arduino. Now if it will turn right, that means it will detect a black tape on the right side, and this will be connected to ground. So the right sensor is cutting the supply to the terminal 3 of the Arduino. So we will see here, okay, so the right motor reverses its direction. Actually, it's momentarily because it will go back again. It is in its normal detection state, which is none. So it will go again on forward direction. So actually, the simulation is not running online because of the CPU load. Okay, this is what exclamation point means. Okay, so on the left detection also, it will turn left. You can see here. So the left motor reverses its direction. So it will go back again to the normal state, which is no detection. So the motor will run straight again. So how about on the stop mode? That means the two sensors will detect the black tape. Okay, so I will click on these two. You can see it will be stopped. Okay, that means that the two sensors is detecting on a black tape on a finish line point of the path, which is the black tape is connected either perpendicular to the path so that both sensors could detect the presence of the black tape. Okay, so that means there will be no 5 volts on the terminals of 2 and 3 because both sensors are in off mode. So we can see 0 means blue. Okay, and 5 volts means red. So we will check on the terminal of the Arduino for terminals 2 and 3. You can see this is now blue. Okay, and all the terminals of the motor is also grounded. So that means there's 0. So both motors are stopped. Okay, so if I see here, I will put it on the no detection mode. You will see on the terminal of the Arduino. So you can see 2 and 3, if there is no detection, 5 volts is supplied here. That means the red color. Okay, so 7, 5 volts on 7, 0 volts on 6. So therefore, the right motor is turning forward. And 5 also is connected. It is positive, and it is 5 volts. And 4 is negative for the left motor. Okay, so it's also running forward. Okay, that means all motors are running forward. How about for the right turn? Okay, for the right turn, you will see here for the right turn. So for the right turn, you can see here on the terminal 3 for the right sensor, there is 0 volts for the right sensor, while on the left sensor there is 5 volts. So there is no voltage now on the terminal 3 for the right sensor. So it's cut off. So that is why it's reversing. Okay. So you can see the polarity also of the motors here. The power supply is being delivered to the motor. Okay. So pin 6 is 0. Okay. Pin 7 is pin 6 is 5 volts, and pin 7 is 0. Okay, so that means it is reversing. Okay, that means it is reversing. You can see it's reversing. That is a right turn. So it's reversing. You can see, while the left motor is in forward because 5 volts is positive. Last time 7 is positive, so it's also in forward, but this time it's being reversed. Okay, so how about if I will put it on no detection again, then I will put this on reverse mode for the left. Okay, so reversing for the left. Okay, reversing for the left. That means you can see here 5 volts for the pin 3. Okay, 5 volts for the pin 3 and 0 volts on pin 2. That means on the left sensor it delivers 0 volts. So let us see here on the polarity again. Okay, so pin 7, which is for the right motor, positive, that is 5 volts, so it's running forward. How about for the positive of the left motor is 5, which is connected to 0. So 4 is positive instead, so it's reversing. Okay, so you can see also here on the output. Okay, so if this is our forward direction, so the left motor is in reverse direction. So I will put it back again. There's no detection, both are forward. So the polarity of the motors again is correct, which is positive for 7 and 5, 5 volts in 7 and 5, 0 volt on 6 and 4, and there is 5 volts both pin and 3 for the sensors. So there will be no detection, so it delivers 5 volts here. Okay, so remember, red is for 5, 0 blue. Okay, So that is how our line following robot works, because of the sensing of the sensors and the reversing of the or changing directions of the motor. So you have to plan uh, all the directions and what you are planning to do, of course, in your code or the program code to be saved on the Arduino. So this is our line following robot.